This lesson we're looking at the locus of points and the locus in particular, which forms the shape of a parabola. So let's look at the locus definition of a parabola. A parabola can be defined as the locus of a point, P, given coordinates x, y, that moves so that its distance from a fixed point, F, that distance is equal to the perpendicular distance from my point P to a fixed line. This fixed point, F, is called the focus, and a fixed line is often called the directrix. Let's have a look. So you can see here the distance from the focus to P is the same as the distance from P to my directrix line down the bottom. As I move P along in the form of a parabola, those two distances remain equal, getting smaller and then bigger. We're going to do a few examples to confirm that this is actually correct. So what is the equation of the locus of a point Pxy if that point P moves so that its distance from a fixed point F, 0, 1, is equal to the perpendicular distance of P to a line y equals -1? Your first job is to write this in words. Let's break it up. So a point P moves so that its distance from a fixed point F. I can just simplify this first in words. So the distance of Pxy from F0, 1. Next I have is equal to. So I can just say that this distance equals and lastly, I have the perpendicular distance of the point to a line y equals -1. This one we just have to have a think about, well, what is perpendicular distance of P to y equals -1? We're going to draw out my point, and then I'm going to draw out the line y equals -1. Now we're looking for this perpendicular distance here from P down straight to that line. Notice if I draw a line straight down from P, my x-coordinate should still stay the same when it reaches y equals -1. So I'm really looking at the distance from Pxy to this point on the line, x -1, because my x-coordinate will stay the same straight down, and we know my y-coordinate on that line is always going to be -1. So we can say that the distance Pxy from F0, 1 equals the distance Pxy to my point x -1. Let's now write this using mathematical notation. Know the distance between 2 points, P and F, could be given by the square root of x -0 or squared plus y -1 squared. Equals, put your equal sign in. The distance from P to x -1, well, I'd have the x-coordinates, subtract them and square them, plus the y-coordinates, so y plus 1, because it's a -1, squared. I'm going to simplify this, and notice here that my two x's on the right-hand side, they will cancel out. And this is something good when you're doing the locus that forms a parabola. Every time you do a locus of a parabola, something, either two x's or two y's, should cancel out under the square roots. Once they're gone, I'm just left with y plus 1 all squared. Now your job, as usual, is to rearrange to make this look like it's in the form of a parabola equation. That's normally y equals something with an x squared, or x equals something with a y squared. So first square both sides. we'll have x squared plus y minus 1 squared, because by squaring this side, the square root signs will disappear. The same with the other side, we'll just be left with what's underneath the square root sign. Then expand both of these sides. Notice that the positive ones will cancel, the y squares will cancel. I'll be left with x squared minus 2y equals 2y. So this looks like it's going to be of the parabola of a form y equals, and then x squared with the constants on the other side. So first thing, I want to take that negative 2y to the other side, and I'll get 4y is equal to x squared. If I take the 4 across by the dividing, I will get y equals x squared on 4. And indeed, this is of the form of a parabola. Next example. Find the equation of the locus of points pxy whose distance to the point, our focus, 2, 0, is equal to its distance, and we can assume it's going to be the perpendicular distance from the line, our diatrix, x equals minus 4. Like usual, start by writing this out in words, then in mathematical notation. If you feel confident, you can go straight to the mathematical notation part. So here I can write the distance of pxy to the point f2, 0 equals the distance of pxy to the line x minus 4, but remember it's a perpendicular distance. So we've got to figure out that perpendicular point. I'm going to draw in the line x minus 4 and my point P somewhere. Okay, if I draw a perpendicular line that connects those two, my point and the line x equals minus 4, notice what happens. The y coordinate, well, this line is horizontal, right? So the y coordinate is going to be the same y coordinate as my point P. That is just y. My x coordinate, well, at the line x equals minus 4, the coordinate is minus 4. So now I have equals the distance of pxy to the point minus 4y. I can go ahead and write this in mathematical notation. And hopefully we see again that y minus y squared, something here will cancel out. So let's neaten it up just a little bit. On the left-hand side, we have the square root of x minus 2 squared plus y squared is equal to, on the right-hand side, x plus 4 squared, the square root of that. The y minus y indeed does cancel, so all we have to do now is rearrange to make this look like it's a parabola. Again, start by squaring both sides. That will get rid of your square roots here. So we'll have x minus 2 squared plus y squared equals x plus 4 squared, and then go ahead and expand and simplify where you can. It looks like my x's cancel, and I end up with something that's probably going to look like a parabola of the form x equals y squared something, something, something. If I want x equals y squared something, 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 what I want to do is isolate a value of x. So let's move the x's to one side and then the y's and the constants to the other side. Then divide by 12 to get the x completely by itself, and we should get that x equals minus 1 plus y squared on 12. This again is of the form of a parabola. It's just that it's going to open sideways. Looks like something in this diagram, and that's why we have a y squared rather than an x squared in this version. Again, this was 5C of the textbook, and I have a feeling you can probably relate to Garfield at some point or another.